All right, so I'm going to try to go a little quicker because now we're just going to go over the actual structure of a neuron. So here on page 435, you're going to see what one ideal neuron looks like with your soma, your dendrites, your nucleus, your nucleolus, got your axon hillock here. So number one, soma or neurosoma. We know what that is. That is just the body, all right? So a neurosoma, as you see here, is just the body of the neuron. So we're going to type here soma or neurosoma. It's just the body. Well, I should just put that down there. That's just the body right there. We have what your axon, you need to know what an axon is. All right. And it says that it originates from an axon hillock, so this actually carries out signal. This is your output. Carries out signal. You need to know what your dendrite is. Oh, by the way, we only have one. All right. Max of one per neuron. Can't have more than one. Okay, for 23, dendrites. You know what the dendrite is. Input. And that's receiving. Receive signal. I'm going to put here may have more than one. Your axon hillock or hillock, I really don't know how to pronounce that. That's pretty much just the trunk. So if you go to slide, where is it? 12-21, it's going to say that an axon originates from a mound on one side of the soma called the axon hillock or axon hillock. Mound of origin for axon. And if you can see right here on the anatomy, your axon hillock is right here. It's this little place where the axon actually stems. Now, this entire piece right here, this entire root is the axon. And it can split and divide, but you still only have one axon, all right? Coming out from one axon hillock, one, which is a trigger zone, all right? You have your initial segment right here. This little bottleneck area is your initial segment. Then everything down here is axon, everything. You don't have two here, it's just one. Okay, you could only have one or none, but you can't have more than one. Give me 1 second. So we're done with this. We're done with dendrites. Now let's go to another page and talk about different types of neurons. So if we move along, we're going to see different types of neurons. We have multipolar neurons, bipolar neurons, unipolar neuron, and anaxonic neuron. Without an axon, I'm going to slide this over here. And you're going to see this on page 436. See how they all have an axon, especially the multipolar ones. Right? They just have one axon. But look at all the dendrites that this one here on the right has. Okay. Look at this bipolar one right here. And look at this unipolar. Now the unipolar doesn't mean that it has like one axon or just one dendrite. It means that you see this little mound right here, this little trunk on the soma, there's only one of those. So there's only one extension, and then it branches out. You have your dendrites here on the left and your axon right here on the right. What receives the information are the dendrites. What carries out the information is the axon. Here we have an anaxonic neuron where you don't have any axons, but you have a lot of dendrites. It's receiving a lot of information, but it looks like there's no output there. But the three that he wants you to commit to memory are multipolar, bipolar, and unipolar. I'm not even going to write that on. Oh, yeah. Hurry up. Let me just put it here. Types of neurons in respect to axon count. And here I'm going to put multi. And this is so fucking slow. All right. So multipolar. Bipolar. Unipolar. And all the way down here, I'm going to put anaxonic. So we know these. Good. Now we're going to move along and we're going to talk about, we're all the way now on slide, if you're following along, 1224, axonal transport. Very important. Axonal transport is referring to physical things that are being transported through the axon. So physical things. So it's physical, tangible things like the chemicals, like acetylcholine, that travels down the soma through these secretory vesicles or synaptic vesicles and reach the synapse. So physical, I'll put slash here, tangible things. Well, electricity is tangible too, so we're just going to physical, parentheses, chemical, things that travel through the axon, like ACH. All right, so that's that. And the transport can be anterograde or retrograde. So anterograde transport, that's just from soma to axon. It's away from the soma. So from soma to axon, I'm going to put away from neuron body. Then retrograde is going back. So retrograde transport is quite the opposite. Movement or transport to the soma from the distal end of the axon. And he talked about viruses that are in the synapse, which is where two neurons meet. That little space there, that little gap, like the gap junction. No, not the gap junction. That little gap from neuron to neuron. There are viruses that take advantage of the exocytosis process of, let's say the neuromuscular junction, and they go into that little synapse knob, and then up in a retrograde fashion up to the body of the neuron. So going up or back up to the soma, that's retrograde, and going down away from soma to axon, that's anterograde. Let me see if I could bring the page here. Could not bring the page because now we need to talk about the supportive cells. But just remember that you have anterograde and retrograde transport. Next we have fast anterograde and fast axonal transport and slow axonal transport. Just remember that you don't have to remember the very specific speeds, but just remember that regeneration in a nerve occurs with slow